Okay, let's dive right into this explainer because today we're looking at a high-stakes reality that is fundamentally reshaping our world. We're going to explore the paradox of China's water crisis and ask a really fascinating question. Could a massive breakthrough in desalination technology actually solve the intense geopolitical tensions happening right now on the Brahmaputra and Mekong rivers? I know, it sounds a bit like science fiction, but this is happening right now.
You know, while we often just think of water as that thing coming out of the tap, it's actually the invisible fuel that is absolutely essential for running advanced civilization. It is literally the silent engine behind everything from agriculture to our brand new green energy grids. In the modern economy, water isn't just a commodity anymore. It's a structural pillar. You simply cannot build or maintain an advanced industrial economy without an unlimited, totally reliable water supply.
To really put this into perspective, just think about the tech you use every single day. To manufacture just one advanced semiconductor chip, the exact kind powering AI data centers, EVs, and the phone in your pocket, fabrication facilities require millions of gallons of ultra-pure water every single day. And we're not just talking clean, we're talking hyper-cleaned water, stripped down to the exact molecule just to wash away microscopic debris. So when freshwater resources are shrinking, expanding these crucial industries becomes an existential challenge.
All right, let's move into Section 1, the transboundary water wars.
This totally insatiable industrial thirst brings us to Asia's great rivers, and it's creating some incredibly complex asymmetrical power dynamics. Just take the Brahmaputra River. It originates up in the Tibetan Plateau in China before flowing downstream into India and Bangladesh. Because China holds that strategic upstream advantage, possessing over 50% of the basin area, the dynamics are inherently skewed right from the start. For downstream India, the Brahmaputra accounts for nearly 30% of its total freshwater resources. You can easily see how this geographical reality breeds a ton of mistrust and strategic anxiety.
Now, if we swing east over to the Mekong River, we see a really stark contrast in the governance frameworks that are trying to manage all this tension. On one side, you have the Mekong River Commission, or MRC. This includes downstream countries like Cambodia, Laos, Thailand, and Vietnam, and it operates on this rules-based, consensus-driven model that's heavily focused on sustainability and sharing data. But on the other side is the newer Lingchong-Mekong Cooperation, or LMC. This includes all 6 river nations, but it is heavily led by China. The LMC is super focused on infrastructure and development, but downstream nations often point out its limited operational transparency, especially when it comes to dam operations.
And because of these totally differing approaches, downstream nations face some really deep anxieties. For instance, unilateral hydropower development can lead to rapid, unexpected water fluctuations. Just look at the Jinghong Dam. They engaged in hydropeaking for 11 consecutive days, which severely disrupted the fish migrations that local livelihoods depend on. Or consider the withholding of over 1 billion cubic meters of water by the Tuba Dam during severe droughts. And then, of course, there's the ultimate fear in India. These persistent rumors of a Grand Western Water Diversion Plan, which is this staggering megaproject theoretically designed to divert the Brahmaputra's waters entirely to China's dry north.
Which brings us to Section 2, the desalination trap. So you might be wondering, with 70% of our planet covered in ocean water, why on earth are nations fighting over rivers? Well, the answer lies in the desalination trap. For decades, traditional ocean desalination using reverse osmosis has been a brutally expensive mechanical loop. It requires generating upwards of 80 bar extreme pressure. That is 80 times the atmospheric pressure you feel right now. This wastes immense amounts of electricity just to shove seawater through these incredibly fragile plastic filter membranes. Naturally, these filters rapidly clog with dense mineral scale and biological slime, and they end up tearing within a few years. And worst of all, the whole process dumps toxic, superconcentrated, chemical-laden liquid brine straight back into fragile coastal ecosystems.
A great way to visualize this is to imagine pushing thick, muddy slush through a fine window screen using a high-pressure power washer. For a few minutes, sure, it works, but very quickly the screen clogs up, you have to crank up the pressure even more, and eventually the screen just rips apart. It is an expensive, high-maintenance nightmare.
To defeat this trap, engineers basically had to step back, throw out the entire concept of plastic filters, and ask a fundamental physics question. How does nature actually clean water on a global scale without using any filters or high-pressure pumps? The answer? Nature uses the sun to evaporate pure water, leaving the salt behind.
Okay, let's jump into Section 3, the salt-free breakthrough.
To finally abandon that 20th century filtration model, Chinese scientists have engineered some revolutionary new systems. One uses a continuous, non-contact thermal crystallization engine that's actually powered by industrial waste heat. Another utilizes this brilliant 3D photothermal grid. For this one, researchers literally wove polymer chains, kind of like sewing buttons into fabric, creating a structure that absorbs over 90% of incoming solar energy. Both of these incredible systems effortlessly flash seawater into pure vapor, naturally leaving the salt behind.
The benefits here are absolutely a game changer. By keeping the seawater in a fluid stream and flashing it into vapor, you instantly have zero plastic filters to clog. There are no massive 80-bar pressure pumps draining the local power grid. There is zero toxic liquid brine being dumped back into the ocean. Instead, the salt supersaturates and drops out as dry, sellable commercial-grade crystals, things like lithium and magnesium, which actually creates a brand new revenue stream. And by running off free industrial waste heat and off-peak green energy, the operational costs drop well below your standard traditional municipal tap water rates.
And that leads us right into Section 4, redrawing the geopolitical map.
This isn't just a clever mechanical breakthrough, it is a massive infrastructure statement. But to understand its true geopolitical impact, we have to separate the fear from the actual hydro reality. Take a look at this data on the Brahmaputra. While China occupies 50% of the basin area, it actually contributes less than 20% of the total water discharge. Most of the river's actual flow originates completely outside Chinese borders, mostly from heavy monsoons in India. Furthermore, that terrifying Grand Western water diversion plan we mentioned, it's officially unapproved and highly unlikely to happen due to staggering costs and massive environmental concerns. A lot of the threat is largely just a perception of power asymmetry.
But here is the really deep insight, the big so what of this whole explainer. If China can cheaply and infinitely supply its coastal industrial megacities and agricultural centers using salt-free ocean water, the desperate domestic pressure to hoard the Mekong or dam up the Brahmaputra for water diversion drops significantly. The technology essentially acts as a giant pressure relief valve for transboundary water disputes.
This kind of technological abundance paves the way for genuine diplomacy. We're already seeing frameworks start to emerge, like the EU-China water policy dialogue, which strongly prioritizes the water efficiency first principle, basically focusing on reducing demand before you try to increase supply. It makes true cooperation highly viable, like finally aligning the LMC's funding power with the MRC's rigorous environmental standards, or conducting joint scientific studies on river fluctuations to actually build trust instead of just building more dams.
By just taking a step back, mimicking nature, and removing those old engineering barriers that made desalination such a nightmare, we have the real potential to transition from an era of diplomatic mistrust and shrinking rivers to a new era of sustainable, infinite resource generation. We can literally turn the ocean from an undrinkable barrier into a reliable, world-sustaining utility.
So, I want to leave you with this one final thought to chew on regarding the invisible fuel that runs our world. Will breakthroughs like salt-free desalination scale fast enough to save our drying cities and diffuse international tensions, or will water ultimately become the hard bottleneck that limits the future of global power? Thank you so much for exploring this vital topic with me today. Keep learning, and I'll catch you in the next explainer.